In this video, I'm going to show you 4 examples of how the discriminant is related to the quadratic equation, and then we're going to determine the number of solutions, which are also called x-intercepts of the graph of the function, and then we're going to sketch it, roughly sketch it. So the discriminant, in case you aren't sure what that is, in your quadratic formula, the discriminant is this piece underneath the radical. It's the b squared minus 4ac piece, just this piece alone. Now I'm actually going to scroll back to a previous video notes that I talked about, and it's right here. In our notebook it's on page 63, but the discriminant tells you when it's positive that you will have 2 solutions, when it is 0 you will have 1 solution, and when it is a negative you will have no solutions, meaning positive will get you 2 intercepts on your graph. If it's 0, the square root, when you add plus and minus square root of 0, you're just going to get 1 answer. You're not really adding or subtracting anything. And then if it's negative, you're going to get an error on the calculator, which means that it didn't actually cross the x-axis. And if that number is a perfect square, then you could have factored. Okay, so this is in a previous video, actually on the day that we learned quadratic formula and discriminant. So here for this kind of review at the end of the chapter, what we're going to do is first state the discriminant, determine the number of solutions, and then graph a possible function. So A here is 1, B is 10, C is 25. So 10 times 10 is 100, and then 4 times 1 times 25 is going to be 100 minus, 100. And I'm going to get the number 0. So if the discriminant is 0, that means I have only 1 solution. And I also know I can factor this. So my factors are x plus 5 times x plus 5. 2 numbers that multiply to make 25, add to make 10. So I'm really going to get 1 solution. And that solution is going to be negative 5. So it's going to look like this. 1, 2, 3, 4, 5. So there's my picture. Now here my A is negative 3, B is negative 4, and C is negative 8. So I'm going to take b squared minus 4ac, and remember, since this is multiplying, you have to multiply before you subtract with your order of operations. So I have negative 4 times negative 4, and then 4 times negative 3 times negative 8. So 16 minus 4 times 3 times, negative 3 times negative 8 is going to be 96. And 16 minus 96 is a negative 80. And if I were to take the square root of negative 80, that would give me no real solutions. So that means somehow my graph is going to be up above the x-axis, and it's not going to cross and get any x-intercepts. Okay, now here I have x squared minus 6x plus 0. So my A is 1, my B is negative 6, and my C is 0, because there's no constant here. And so b squared, negative 6 times negative 6, so this is what I'm doing here, and then minus 4 times my A times my C, 36, well this is going to be 0, because anything times 0 is 0. I get 36. This is a positive, so I will have 2 real solutions. And this is a perfect square, which means I could have factored. I notice here I have a GCF that I could have taken out of an x. Set each factor equal to 0, which we're going to do in the next picture here. I have 0 and x minus 6 equals 0. I'm going to get a solution of 6. So I'll tell you roughly what it will look like. Pretty cool, huh? Okay, now, last one over here. A is equal to 1, B is equal to negative 8, C is equal to 7. My b squared minus 4ac is going to be negative 8 times negative 8. And then 4 times a of 1 times c of 7. This would be 64 minus 28. I get, oops, I didn't hit enter, 36. Oh, again, a perfect square, and it's a positive, which means 2 real solutions. Can you factor this? 2 numbers that multiply to make 7 and add to make negative 8. How about a -7 and a -1? I'm going to have two solutions, and I'll show you in the next unit how I know how to do this. But we're going to have 1 at 1 and 1 at 7. Super cool. Anyway, that's roughly what your picture is going to look like.